Hello, good morning. Can you hear me?
Good morning. Yes, I can hear you.
Okay. Okay, sorry for delay. Okay, so now we'll start. So basically, today talk about
Yes.
that water salinity monitoring, how we can easily monitor the salinity level of water. So let's go. I simply open my share my screen. Okay, can you see my screen now? Is it visible?
Yes, I can see it.
Okay. Let's go on to the station. Basically, today I talk about that how we can easily extract that salinity of water. So that's why salinity basically it's very important element of water quality monitoring. So for the salinity, when you want to monitor, we have to just follow this type of step. First of all, data acquisition. Mainly in this time, you just work with the Landsat or Sentinel imagery. Both of images is also work well for that salinity. And then pre-processing of the data, then calculation of salinity indices, further check the validation and analysis and visualization about your data. So
Okay.
in this time, data acquisition, you can identify suitable satellite imagery for your study area and time frame. It can be Landsat or Sentinel imagery are commonly used for water quality monitoring due to their moderate resolution and their frequent revisit time. And access data in Google Earth Engine. So basically, we can easily access all of dataset from Earth Engine data catalog, Landsat, Sentinel, both of them. We can easily get it from Earth Engine data catalog, and we can easily use this type of data for monitoring the water quality monitoring. So this is the first step. We just simply call our satellite imagery from Google Earth Engine data catalog, and then we just pre-processing the data. So mainly filter and selected the image that cover your study area and time period of interest. Simply filter. Then apply the atmospheric correction method or remove the atmospheric effect from the imagery and improve the accuracy of your water salinity estimation. And also remove the unnecessary pixels such as cloud and haze. So these type of things we simply remove or cloud maxing. Then we can get that very clear satellite imagery. So this is our pre-processing step for removing the cloud and haze. And then further we calculate the salinity indices. So we can use there the different types of salinity indices, such as we can see. One is that MNSI. So it's that modified normalized difference salinity index. And SSI mainly salinity index, which are tolerant for the salinity estimation. So first of all, you can see NWI calculation. We are just compute the normalized difference water index using this formula NDWI. Okay, so green minus near infrared divided by green plus near infrared. So this is the NWI formula. From this NWI, we are just extract the water body. Okay, then can be used to estimate the water salinity. First of all, we are just use the NWI and then extract the water body, and this water body we are used to estimate the water salinity. And also you can see for salinity we are using this type of indices. One is the modified normalized difference salinity index or salinity index, as well as we can also find out that the lot of salinity. Suppose I simply search on the Google, then it will also provide me a lot of indices for salinity. Just I simply search here salinity, salinity, or I simply search as suppose water salinity index. Now it also probably simply go to this image, so then you can get a lot of equation. You can see, suppose you can see.
Okay.
Suppose here you can see, just simply go to this paper. Okay, so here you can see different types of salinity index we are also use. Such as here you can see salinity index equal to root over green band multiply with red band. Also you can see salinity index 2 equal to root over z square plus r square plus near infrared band r square square. We can get all of those things. Also you can see about another is that normalized salinity index, which is that you can see r minus near infrared divided by r plus near infrared. So also you can see basically this is the different types of equation mainly used for the Landsat imagery. You can see also see about the difference about this type of index for which provide this type of equation. We also get the reference also from here. So in this time we are just use this type of equation, and then further we calculate about the salinity. Okay. Uh, and then also you can see about that, suppose after calculating the salinity, we also check about that validation. Okay, so we have to check the validation. For the validation, we need the ground truth data. So we'll be collecting some ground truth data on water salinity from the in situ measurement or existing database for the validation purpose. And accuracy assessment, compare the remotely sensed salinity estimate with ground truth data to access the accuracy to the Golat engine based approach. Okay. So now we also talk about that also some validation after creating this map, and then further we try to analyze and visualization. So basically we can get the three type of visualization. One is the temporal analysis. Temporal mainly it's one kind of time series chart or also temporal trend in water salinity over the study period by aggregating and visualizing the computed indices. Then spatial analysis basically it assesses the spatial pattern of water salinity across the study area using the spatial analysis tools in Google Earth Engine. And then further we are just create the map, general map, time series plot or histogram, visualization, distribution of the variability of the water salinity. So let's go try to practically discuss all of these things one by one. So you can see this is the one kind of map. This is the Dead Sea area. So in the Dead Sea water, we find out that very high salinity all time. Okay, Dead Sea mainly. When the Dead Sea, we find out the very high salinity. So that's why you can get this type of result here. You can see. So it show that the salinity almost the full water body. We can get that almost full water body. It show about the very high salinity level in the Dead Sea. And this is the satellite imagery. So first of all, we extract the satellite imagery. From this satellite imagery, we extract the water body. So this is the water body, and from this water body, we are just applying the salinity index and calculate this type of map. So in this map, we find out that this study area is almost all of water body have the high concentration of salinity. So you can get the some this type of area, we can get the low, but almost all of water body show the very high density of the salinity in the Dead Sea. So let's go. We try to extract the practically one by one. Then I hope we can really get this idea how it will work. So just
Okay.
I simply open my code editor. I also open my okay, I will also open the QGIS software. I will show you that ground truth data. Just a simple open. Okay. So let me open. Yeah. So also you can see in this time I also show you that suppose in this time this is my in pseudo data for my study area. So here you can see I have just this type of column. One is that longitude, another is the latitude, another is the ground truth data about the salinity PPT. So this type of point, I extract the information for salinity. For each point, it's showing the salinity. It's my ground truth data. Okay. So this data I use for check the validation. Okay, for my study salinity information for same location. For the same location, we also extract the salinity map
Hello? Can you hear
information
me?
but on our map. And further, we are just compare the result with our ground truth data, which I collect
I
from the
can't hear
field.
you.
And then another column I also create, which I get from the satellite imagery. Then further, these two things we are just use for the compare and then check the accuracy. Okay. So, okay, can you hear me now? Yeah.
Yes, I can hear you.
Okay.
Perfect.
Sharing it. And in this time, I also use, suppose I already have the shape file of my river, which study area I want to choose in this time and collect the training sample for this river. So just I simply show you the shape file. So just I open this river shape file. This is my shape file. I just open it in my QGIS software.
Okay.
So here you can see this is that shape file of my study area. There's a mangrove forest. In the mangrove, we try to find out all of water body, what is the condition of the salinity. We try to find out this type of result. So just
Okay.
near it, so better just I want to attach that base map, then you can easily get it for this study area. Just I simply attach that uh, Google satellite map I want to add in here. Okay. So here you can see this is my study area. So it's a mangrove forest between Bangladesh and India. It's covered the mangrove forest. So
Okay.
now for this study area, I want to extract the water body, and further this area I want to use for making the salinity. We try to find out the salinity condition about that. So let's go. So first of all, I simply open ROI. So this is my study area. So just I simply put here map dot add layer and this ROI, and then I just simply put the map dot center object. Object is ROI. So now put at the zoom level, suppose 10. Click the run. So now it visualize my study area. Is this my study area? So in this study area, you can see there are a lot of river. Okay, you can get that there are a lot of river. So now I want to extract all of those river, and further this river I want to check what is the condition of salinity. Okay.
Okay.
And now I want to use the imagery. Suppose I just simply click on the browse data catalog, and now I want to work for that. Suppose Landscape imagery, top of atmosphere, the landscape imagery. And then put at that Landscape 8. And all time we are using at the top of atmosphere for our make the water quality parameter. So just I simply copy this snippet from here and then paste in my study area. Suppose I take a variable image equal. Further I simply filter it. So how I can filter? Just put here the filter bounds, so then it will be intersecting only for my study area, which is RY. Then put here that filter metadata. It mainly filter the image cloud cover. So in this time you can see it also have a image properties. So I choose the cloud cover. Cloud cover. Simply copy the cloud cover, and I choose here the less than 1% cloud cover. So I want to take the very less cloud cover imagery. So put here the less than, and then set the 1. Further, I simply put the time period. So put here the filter date, and put here the start and end date. So in this time, you have to check your ground truth data. Suppose when the time period you want to check to collect this type of ground truth sample, we have to use the same imagery, net the same imagery. So in this time, in this image, I want to collect for the year of 2020. So just I put here that 2020, suppose 1st January from 2020. It also better if you know the what is the exact date about that. It also more better. Then you can use the for this only for the single date image of this time. Then you will also get the more better accuracy.
Okay.
So in this time, I just take that whole year of 2020 and then create the median composite. And further, these things I just clip with my study area, which is ROI. Okay, so now just show the imagery. So just map dot add layer, and then call this image, click to the run. So now it will show the imagery of our study area. It look like that. So just I want to add the visualizations, click on here, and for the example I put here that red, then put here that green, and also blue, mainly RGB color, red, green, and blue. Custom stressing 98%, and further apply it. And now we are
What's the
just
difference between, sorry, what's the difference between the filter bounds ROI and the clip ROI?
okay. Filter bounds mainly it filtered this image collection. Okay, suppose this image collection is for the global. Okay, whole world for this image collection is available. But in this time, I need the image only for my study area. So for that, I simply put the filter bounds function. This function help me to get only for those images which images are available in my study area. So now and clip function basically it's a clip. It's just clipping with my study area. Suppose I have a study area. This image just clip with my study area. If I don't use the clip function, then you can see what happened. It just also have other tiles also showing. Suppose is the in this time you can see. Just I simply import that and try to show you that without clip function, it show the result for that other area also. It not show the result only for my study area. It also show about that whole study area, whole cover. So click to the run, you can see in this time. Without I just simply commenting this clip. In this time, clip is not work. So in this time, we can get the result. You can see look like that. Okay, you can see it just show this type of result. You can see. Okay, you can see this type of imagery also in here. So basically, filter bounds came all of imagery. Filter bounds came all of imagery. Okay, and from here, when I just need only for my study area, then I just use the clip function. So now it's clipping with my study area, and just I can get the image only for my exactly my own study area, just clipping. Okay, so now we can get this type of
Okay.
imagery here. You can see.
Okay, got it. Thanks.
Okay, so now from this imagery, I just extract the water body. Okay, so for doing these things, we are just extracting the water body, and further this water body, we are just calculate the salinity index. So for calculating the salinity, I just take a variable. Suppose I put the variable name is that uh, salinity, and I put here that element name, suppose image, and curly bracket. In this curly bracket, I just put my argument. So in this time, first of all, I need the equation of the salinity. So here you can see there we can get this type of equation for calculating the salinity index. Basically, I show you that here you can see. Here you can see this type of equation. Suppose I want to use the first equation, SI equal to root over green band in my asset, and further we also use it for check the validation or accuracy. Now it working.
So did
So
you save
yeah,
the previous one as a CSV or did you
no,
import
we
CSV?
created, suppose in this time when I go to my ground, mainly my field observation,
Uh-huh.
I take the training sample and also take this type of data. Suppose this type of latitude longitude I also check, get from my study area. When I
Mhm.
visited my study area, I just simply use the GPS tracker, and then find out the longitude, latitude, and take the training sample from water body we collect from here. And in the laboratory, we are just test this type of salinity level, okay, of water for this
Okay.
location and for this location. And when I want to go to when my study area, we just simply take this type of point. Okay, suppose for each location we take the longitude and latitude, and also take the
Mhm.
water. And further we check the water, we calculate the salinity for my study area, for my each
Okay.
location. So in this time, I just use import this all file, simply import in my Google Earth Engine platform. Okay, so you can
Okay.
say simply import it, it will be done. So just simply run it, and here you can see, yeah, so you can see this is the file. I simply import that. So
Mhm.
in this file, mainly we can get the it imported table. I put it, suppose it's a points. Okay, so basically it's one kind
Mhm.
of point. Suppose in this time I want to add all of points in my study area and then check what is the condition about that. So here you can see I simply put here that map dot add layer. I call the points. Suppose I put the point color as a red color. So now check about this all of point. Where is it? We can easily find out on a layer. Okay, so here you can see I find out. Okay, we can see also we can take the some point from also from here. Also, you can see we can get just a check it. You can see this is my point. This is my study area. I just simply extract this value from here. This type of river.
Mhm.
Also, you can see I extract the polygon from here. So these things I physically visited, and then we collect this sample from this river. Also, you can see some other point also available from here. So you can see.
Okay.
So now further, after collecting this training, this type of point, now we are just extract the pixel value. Suppose this type of point. What is the pixel value for this study, for this satellite imagery we got? Okay, so, and we already know about the result. What is the ground truth data? We already know. Ground truth data we already know. So now we are just checking the pixel value from our point, from our study area, from our satellite imagery. What is the value I can got from here? So for that, in this time, we are just extract the another Excel file or CSV file, which is including our observed data from the satellite imagery. Salinity, and I also need the another column which I gain from that ground truth data. So put here the salinity PPT. So write here the PPT full name PP. So now I also put the all of the selectors. It's not need remove that. So now click to the run. So you can see here now our task tab will be running. So from this task tab we can easily download the data in Excel file. You can see data to run it. So now we can get that ground truth data, also get that satellite measurement data. Both data, actual value and satellite predicted value. Further, we are just compare these two data, what the correlation, what the accuracy, we can easily compare. You can see it will be done. So let me open now data from here. This is a CSV file. Simply open
Mhm.
it. Okay, so now we can get only for the 1 point data because only for the 1 point is successfully overlay with my NDWI or my water body. So that's why this time we can see we
Okay.
can get that only for the 1 point data. So
Mhm.
this is my coordinate about that. You can see this data is uh, successfully overlay with my map. So that's why you can get this
Okay.
type of data. Longitude value, latitude value about that. Also salinity
Mhm.
value, which I get from the satellite imagery. Another is for that my ground truth data. Okay, you can see we can get that ground, we can get the 1.5 and salinity we can get 0.1. So further, we are just check about the accuracy. When you can get the more data, then you will get the more better result. So in this time, this is the process. Okay, suppose you can take the training sample from your ground, and further this training sample is simply import in the Google Earth engine, and further we also get this type of data from here. Then this data we use for that checking and validation about that. Okay, so we also check the validation for, I'll show you that for the previous class about that, already show you that, and I'll also show you the for
Mhm.
the again for the next class how we can easily use the Python environment and check the accuracy when I have the data for the two column. Suppose one is that satellite imagery, another is for my ground data, then we are just compare these two data and check the accuracy. Okay, so you also try to watch
Mhm.
the video again and try to do this type of things. I hope you can got it. Okay, so I will send you for the today's recorded video class and also send you this practice code. You also try to practice for your own study area and check the
Mhm.
salinity level about that. Okay.
Okay. Yeah, yeah, sounds good.
Okay. 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 Thank you. Okay, I will send you all of the
Okay. Yep.
details. Okay. Have a good
Thank
night.
you. See you
Okay. Bye.
later. Bye bye.